Okay, in this presentation we are going to look at probability distributions with Julia. In this particular presentation we are looking at the negative binomial distribution. This is a discrete probability distribution that models the number of failures in a sequence of independent and identically distributed Bernoulli trials before a specified non-random number of successes, which we're going to denote as R, occurs. Probability of success is denoted P. So we call X our random variable, and that is the number of failures in the sequence, and it's a negative binomial distribution with the parameters R and P. So there we have that there, okay? Now, just as a quick remark, there are various other formulations of the binomial distribution. We'll just go with that particular definition of the binomial distribution as it stands for this worked example. But there are other ones, so just watch out for that, okay? So we're going to set up our packages using distributions, and also I'm going to have using random and using statistics just installed. So for all of these probability distribution presentations, I just have all three of those packages installed by default. So here's our worked example. A large lot of tires contains 6% defectives. So we have a very large warehouse of tires, but there are a few defectives here and there. They're 6%. What we need to do is pick out 5 tires for a car. Okay, that's the four wheels plus a spare tire. Okay, for the back of the car. Now, so find the probability that you find 2 defective tires before you find 5 good ones. Find the probability that you will find at most 2 defective tires before you find 5 good ones. Find the probability of finding 2 or more defective tires before finding 5 good ones. And what is the mean and the variance of the number of defective tires before you find 5 good tires. Okay, so what we have to do here is define what a success is. Now you can approach this different ways, but I'll just sort of set it up in this way. And remember, there are other ways of setting up your whole negative binomial distribution experiment, but we'll just go with a very simplistic example here. But read up about it, because just like the geometric distribution and some other probability distributions, there are multiple setups, so you have to be sure which one you have. Anyway, here the success is finding a good tire by random selection. Okay, the probability of that success is 0.94. So if 6% are defective, that means 94% are good. And the number of successes that is required for this particular experiment, we need to find 5 good tires, 4 for the wheels, and 1 for the spare. Okay, so R is equal to 5. So I'm going to set up this here, NB dist. This is my specification for the negative binomial distribution. Okay, so this is the main part here. This is the actual bit of Julia code, and it comes from distributions. Negative binomial, capital N, capital B, R is equal to 5 and P is equal to 0.94. I'm saving that as NB underscore dist. So let's run that. Okay, there we have it there, and that means NB underscore dist is all set up. Okay, so the first thing we have to do is find the probability that you find 2 defective tires before finding 5 good ones. Well, essentially what we're asking there is calculate the probability that X is equal to 2. So this is a discrete distribution, so we can use the PDF function, which normally means the probability density function, but in the case of discrete probability distribution, this is the probability mass function. So probability of X equals 2, so X, this essentially is contained in this object here, NB underscore dist. Okay, PDF, and X equals 2. So let's run that. So it is 0.0396, so just about 4%, just under 4%, 0.0396. Okay, what is the probability that you find at most 2 tires? Okay, so this is the probability of X less than or equal to 2. So in this case, we are going to use the cumulative distribution function, CDF. But apart from that, it's very similar. Probability of X less than or equal to 2. Here, the less than or equal to is contained in this command here, cdf, and x is essentially a random variable that we have specified above, and all the information is contained in nb_dist. So it is a very large number, actually, 0.9937. Okay. Find the probability of finding 2 or more defective tires before finding 5 good ones. Well, essentially, let's just look at the various approaches here. Well, first off, we can look at the probability of finding no defective tires, which means you find 5 good ones straight away, or the probability of finding 1 defective tire, which is 1 there. So 0.733, okay, that's the probability you get 5. The first 5 you find are good, so you're ready to go. And there's 22% chance that you find 1 bad one, so you have to pick out 6 when there is 1 bad one there. So that's 22%. So the probability of that, both of those cases combined, is 0.9540. Okay. Now we want the complement of that, probability of x greater than or equal to 2, and that is 0.0459. Okay. The last question, find the mean and the variance. Okay. And so essentially what we do is go mean of NB_dist. So this will actually provide the analytical solution. And it is 0.3191. Okay. We weren't asked for the median, but let's look at the median anyway. 0. That makes sense, really. And the variance is 0.33954. 952, sorry. Let's just actually go for standard deviation, just to see what we can do there. Standard deviation of NB_dist is 0.5826. So that's it. That's a straightforward enough one, and we'll leave it there.